Hello! Today we're going to look at how to solve radical equations. Now we have solved equations using the square root symbol to help us, but this time we're going to go in the opposite direction. Now you will notice first a definition. An extraneous solution is an answer which does not check in the original equation. With this type of equation, radical equations, it is possible that you could get an answer or two that will not check in the original problem. So you will need to be sure and check all solutions. Now let's start with the first example. Our first example A here. It says to solve and check. The idea is to isolate the radical symbol. So isolate the square root. Get that on one side of the equation first before you begin. Now, example A already has that done for us, so we can skip right to the next step. The next step is to square both sides. So let me write that out here. Square both sides of the equation. You recall anything that has to do with solving an equation, what you do to one side of the equals, you have to do to the other. Now when you square that radical symbol, that square root, they inverse each other. So they will cancel out, leaving just the x plus 1. On the other side, 7 squared is going to be 49. From here, it's pretty obvious how we need to solve and get the x by itself. If I simply move that 1 over, it becomes a negative 1. So x is going to equal to 48. Now I think that's my answer, but I better double check it. So let me go over here to the side and check that answer in the original problem. Again, the original problem was square root of x plus 1 equals 7. Notice I left that empty blank for the x. That's where I'm going to substitute in my answer. 48 plus 1 is the square root of 49, and that's equal to 7. And that gives me something that's true. When checking, as soon as you see that it's true, you can stop the process right there. So I am assured that 48 is the true answer. Now let's go ahead and look at a second equation. Equation B. You'll notice in equation example B, the radical or the square root symbol is not by itself. So the first thing I need to do is move over that 3. So I will end up with square root of x plus 3 equals x minus 3. Remember, when I move that plus 3 over, it becomes a negative. Now I can square both sides. The square and the radical symbol, the square root symbol, are inverses, so they cancel, leaving me x plus 3. However, on the right-hand side, I now have x minus 3 twice. I'm going to have to use good old FOIL method. Remember how you multiply polynomials, first, outer, inner, last? I'm going to need to multiply x minus 3 and x minus 3 together on the right-hand side. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x. And negative 3 times negative 3 is positive 9. Let me combine like terms. X plus 3 equals x squared minus 6x plus 9. Now I need to move everything to the same side because I notice this is a polynomial with x squared. So the proper way to solve this would now be to use the factor method, which we have used a couple of times before in previous sections. So I'm going to move the terms over. I'm going to move the x over, so it will become a minus x. I'm going to move that positive 3 over, so it will become a negative 3. Canceling and leaving me 0. Now I have negative 7x when I combine like terms, and I have positive 6. This is a type 1 trinomial, so I'm going to factor that. I have x times x. If you remember type 1 trinomials, look at the last term. The last term is positive, so that means use the same signs as the middle. So I'm going to have a negative and a negative, same signs, same two signs, and same as the middle. Now what multiplies to give me 6 but would add to give me 7? That's right, 1 and 6. So I have two factors. I now will solve each of those. Let me move up here. I have x minus 6 equals 0. And I have x minus 1 equals 0. You can probably see the answer right off the bat. If I move the 1 over, that's going to give me x equals positive 1 as an answer. If I move that negative 6 over, that's going to give me x equals positive 6 as an answer. Now, it looks like I have two answers, but I have to check these in the original problem. So here we go with our checking process. I will take the original problem, and everywhere there's an x, I substitute in my supposed answer. So I have x plus 3, and then another plus 3 is equal to 1. Well, 1 plus 3 is 4. Square root of 4 is 2. 2 plus 3. Oh my, that's not equal to 1. 5 equals 1. See, that's not true. So if you get something that does not check and is not true, you're going to have to go back and not use that solution. Let me check this other one. Maybe this other one will check. I'm going to check it in the original problem again, so I'll have 6 plus 3 under the radical, then another plus 3 and an equal to 6. Well, 6 plus 3 would be square root of 9. Square root of 9 is 3. And 3 plus 3 is 6. That is a true statement. So the only true answer I have is positive 6. And that gives you an example of what is extraneous. Extraneous is really just an extra answer that you get that is not correct. Hope this helps you solve those radical equations.